Welcome, and thank you for joining us for our webinar today, the Technical and Cultural Challenges to Embrace Open Source. We have PLUMgrid and S5 here to present and share on this topic. Just some quick housekeeping before we get started. If you have any questions throughout this session, please be sure to use the Q&A window. It's typically located to the right side of your screen. We'll do our best to answer the questions throughout the session, as well as we'll save time at the end for some live Q&A. So please use that window, and we'll be happy to address those questions. So without further ado, I present to you today our host, Ali Hayam, and he's a Principal Engineer and CTO Office at PLUMgrid, and Sean Wormke, Director of Product Development in the OpenStack Group at S5 Networks. So to kick it off, I'm going to pass it over to Ali from PLUMgrid.
Thank you, Deborah. Good morning, good afternoon, good evening, wherever people are dialing in from. It's a pleasure to be here. Today we're going to talk about a very interesting topic, which is this OpenStack transition that PLUMgrid went through. I've been with PLUMgrid from 2012. So I've had the privilege of seeing this transition happen firsthand, and this is among many fascinating things that you see as the startup is growing from a cowboy style, just doing everything themselves, to something which is much more structured for customers and thinking about upgrades before you think about anything else. So I've seen this transition, and open source has been a very fundamental part of this journey, and that's what I want to talk about today. Oh, I can't see the slide. Oh, okay. Thank you. So I'm going to start talking about the two themes that we had. So we, from the get-go, had an open source strategy, and I'll talk a little bit about it. But PLUMgrid did not start as a company that wanted to be an open source company. So we did not start off that way. We did not, in all fairness, most people in the world, I think, and PLUMgrid included, did not anticipate the impact that open source software would have in the world of software over the next few years, from 2012 to 2016. So I will talk about how we started off, and while we had an open source strategy, what the strategy was, and how that evolved into a much, much more broader and deeper part of our culture inside the engineering organization as we evolved over the past few years. So PLUMgrid in 2012, we were out to change the world. We were building one of the coolest STM products in the world. We were building a scale-out data plane for fully programmable that could actually be used to implement any network function. And it could be managed and controlled through multiple interfaces. Since it's scaled out inside the data plane, they were just basically the control plane interactions were minimal, and we knew that this could actually this could scale out to gigabits and terabits per second, simply because all the processing were distributed. But we were really thinking about a networking problem. At the same time when this was happening, open source was, of course, Linux was there. There were other open source projects that were getting a lot of traction, but it was not really as insane as it is today. And in all fairness, we did not anticipate it to be where it is today. Adoption would be so quick of open source software. So when we started off, we knew there was one component of our product that definitely we had to open source. That was the iWizer, our core data plane engine. And we wanted to upstream it into the Linux kernel. The reason for doing that one strategy, so that was the only open source strategy that we had from the beginning, because we knew that iWizer is a technology that has a potential, once you have a programmable data plane that can run safely inside the Linux kernel, that has a potential to change applications way beyond what we are thinking of. So the application and use cases for that technology were way too broad to just keep it hidden inside the four walls of PLUMgrid. So we wanted to kind of make sure it's available to the world. And as we can see now that it is available in 3.1 plus Linux kernels, it's being used for not just, we use it for networking, virtual networking, but people are using it for security, for tracing, for CPEs, for MSP use cases, and so forth. So this was one technology we knew had a much broader impact, and we wanted it to transcend beyond just the business objectives of the present business objectives of PLUMgrid in 2012. While we were only focused on this particular aspects of open sourcing, our team composition looked something like this. So we had two teams. Of course, we had an open source team that was working on upstreaming into the Linux kernel, but that was a very small fraction of the overall engineering team. So about 10% of engineers, a few engineers just focused on this project and just making sure that they're working with the community and they're getting everything done. The rest of the bulk of the team, about 90% of our engineers were working on the closed source control and management plane functions that were used to operate this data plane and build different network functions on top of it. So the composition of the team, as you see, was very skewed heavily towards a very closed source thing. Interestingly, I mean, even from the beginning, the cultures of these two teams were pretty distinct. It was very interesting to see that they are distinct from the beginning. So the open source people were almost driven by the need for perfection. I mean, they would discuss with anybody and everybody that could get their hands on before they pushed the first set of code on the community. Maybe for the fear of the community rejecting it, or, they're getting public feedback on their code. But it was like, the culture was like, they'd get a lot of feedback. They'll think about all the corner cases. They'll do review after review of documents and some prototype code before they actually pushed anything out on the web. And they were much more open to feedback. So they were actually almost like asking you to shoot down their proposal because they knew if you didn't in-house, somebody in the community would, and that'd be public. So that was another, the cultural aspect that we saw very distinctly in the open source part of our team. The other team, which was really delivering the product and the releases, were main focus on, they were driven by the release deadlines. They were following a very, very waterfall-like model, where they would basically plan for releases every 3 to 6 months, and generally those releases would take a month or two more than they were planned for. And more importantly, even when they release and we release with the right quality, there was a lot of maintenance and code rot debt that kept accumulating over time. Whereas on open source side, people were much more agile. With every build, with every change, they were actually able to, once they got the base code in, they had to maintain it, because anybody who touched their code and had an impact on it, they had to review their code, and then they knew what was coming and how it would impact the piece of code that they had already upstreamed. So we saw that their ownership of the modules that they had and the maintenance of the module that they had, so the consequence of the ownership was much higher in the open source team. By the way, this trend has now changed. So, I should highlight, at this point, about 40% of PLUMgrid engineers have upstreamed code into open source communities or are actually driving open source communities of their own from the PLUMgrid platform. So there's a heavy shift, and I will talk about how that shift happened over time. So, like I said, about 40% of our team today actively contributes to open source projects or runs open source projects. But even beyond that, open source is embedded into the fabric of our engineering organization at this point. And many fundamental components of our system rely on it, and many of the management and even day-to-day operational aspects of our engineering organization rely on open source software. So at the bottom of this slide, you will see all the different projects that we're using. This is not comprehensive by any means. This is just a high-level view of, these are the projects that we're actively either utilizing or contributing to in the open source world. But just to talk about a few important aspects. So open source is part of our platform as well. So some of it, we use libraries from open source in our, like you saw, the data plane is all in the Linux kernel at this point. Our remote procedure call, the library, which is a distributed RPC fabric, is relying heavily on streaming libraries that are used from open source. We use storage libraries from open source projects as well. But most importantly, probably the VNF element, because even being a networking company, we do rely on some of the open source software, and using our service insertion architecture, we are able to scale out existing VNFs that exist in the world. For example, for routing or firewall or load balancing, we can take existing applications that exist in the world and just build the control plane functions and the data plane to completely scale out with IOvisor. And that the service insertion architecture allows us to even utilize these active network function projects that were built for boxes or commodity x86 machines and bring them into a distributed scale-out model. Similarly, the solution components, for example, cloud management, we build cloud management SDN platform for the cloud management system called OpenStack. So we did not anticipate OpenStack would be this big in 2016, right? I mean, so we knew it was getting traction, but there were other projects at that point as well that were closed source that had a lot of traction and a lot of market share. So, but this is one of the, again, validation of, this is these kind of elements of OpenStack getting so much traction in the world and taking over the cloud management space as a reasonable and very viable alternative to closed source products was, again, driving our team towards doing more and more of the community work, being more engaged in the reviews, in the community meetups, in contributing code, making sure we're attending the meetings and reviewing their specs. So the world is sort of like was changing while we were also building our product, and it was forcing us to become more and more engaged with these open source communities. Even for storage and security, we rely on some of our open source projects. Even on GUI packaging, operations, these things heavily rely on open source software at this point. Packaging in particular, we have open sourced almost every single aspect of our products packaging, all the integration with different distributions. OpenStack distribution is either on big tent projects inside the OpenStack community or on our own GitHub repository. But this was definitely one place where there was no point in just keeping it in-house and maintaining it in-house. Similarly, operations, so there's been tremendous leaps and bounds progress in free open source software in terms of operations. So there are bits and pieces available which can do analysis of your logs, store them in databases which already have replication and the databases that already can scale out to a large number of clients. And one of the things that we are trying to avoid doing, and I'll talk more about it later in the presentation, is to try building these things ourselves. And we did make those mistakes. I'll talk about them later on. So instead of trying to build all of these things ourselves, we are relying heavily on these things and just bringing the business logic or the workflows as to how they should all flow together in the form of a business report or a dashboard that people can use to operate their cloud rather than reinventing the wheel in terms of what the open source community is already providing. Our CI infrastructure relies heavily on Jenkins and other projects, and we basically have a lot of open source presence over there. We've not contributed much back, but yeah, at least we rely on even on CI and ticketing systems. We rely on open source software. So what prompted this transition, right? Where we have approximately 50% of our workforce working on this in some shape or form now. So first of all, we realized that we don't have to do it all. We were of the view that, engineering workforces. Engineering workforces want to build everything themselves and they want to maintain everything themselves. We realized in this new world, that this model does not fly. We don't have to do it all. In fact, we realized we can't do it all. Being a startup that we were, doing it all just does not make sense. Even if you could build it, even if you could build it better than where the community is, just the can should not mean that you should. So just because you can build it does not mean you should build it. And that's a realization that really took us a lot of time and heartache to come to. Because engineers being engineers are like, yeah, I can do it, but this community is they're still catching up, they're just figuring it out, I'll just write some code. So the idea is you can probably, even if you can write it better, if it's not the core of your competence, if it's not the core of your product, I assure you, you will die maintaining it. Because the code, just writing it and getting it to work is not enough. Somebody has to maintain it, and having the limited workforces that we have in our engineering organization, we just do not have the bandwidth to maintain it. And since it's not the core of our product, why do you want to just keep it in-house and maintain it yourself? So this was one of the biggest, stark realization where we understood that everything that is not the core of our product, like I talked about packaging and operations, everything we can open source, we go ahead and open source it now because we want the community to contribute and grow those things, whereas the business logic or the reporting aspects and all of those operational aspects are the ones where we actually focus our energy as to how to maintain those in-house, but not the base technology, because the base technology, when people take it and not only they use it for the use cases that you have in mind, the community comes up with very interesting and unique use cases that you've not even thought about. So it serves a broader good as well. And of course, I mean, this was more like I've been giving an insight out perspective of what engineering wanted to do, right? I mean, they wanted to save energy, cost of code maintenance, and so forth. But we also had customers asking for it. This whole transition into open source software, customers were now, asking some very deep and insightful questions about why some of our components were closed source. How would they integrate with things that they are already deployed with their own DevOps team? So, for example, one thing that has been a common question is kernel changes. So if you insert a kernel module, people want to know what's inside the kernel module. What impact can it have? How would it impact upgrades? Because you're only part of a solution, right? We have an SDN layer, and then there are 100 different elements of the cloud that all run inside the kernel. So are you going to impact it? How would you wall garden your component so that it does not impact other components? That was one question that a lot of people were asking us. Lots of customers are moving towards this DevOps revolution, so people know that's the right way to operate. I mean, if you really want to be a cloud and an Azure cloud company, this is the right way to operate your Azure cloud. And they basically were going into that transition, and they had teams, very smart people who were managing, operating these clouds. So they basically were they were forcing new buying behavior. So earlier people would say, I just want to buy a product that does everything, one size fits all, and just I'm going to just use that. And if I have a problem, I pick up the phone and call somebody. Now with these DevOps people, they're bringing in CI infrastructure. So even if you have hundreds of components, and we have customers who have hundreds of components in a solution, they actually build CI infrastructure so that all of it can be tested automatically. Any of those components goes through an upgrade cycle. Any of those components has a security patch. They have systems in place already, continuous delivery systems already in place that can actually apply that patch, make sure it's not going to break anything in the production cloud, and then roll it out. And the ability of customers to be able to build these kinds of CI infrastructure, CD infrastructure is essentially a key transition that has forced this new behaviors in the buying attitudes as well. The second thing is, of course, hiring another company to build a one-size-fits-all product, then the cost of support and services that comes with it is also exorbitant. So the total cost of operation goes up significantly. And our customers, since they were already building the DevOps team, they were like, why not just use those teams to maintain and support it and ask the community wherever we can. So we have customers who have actually bought technologies that did not bought the support contracts from those solution providers. So the vendors actually are not providing support because they know they can actually go and ask the real developers in the community. So not go through the 3-level support cycle, but directly cut to the chase with the developers and ask the question directly. So this is also another trend that we have seen in our customer base. Another important business rationale for this is that customers want assurances that the technology is not tied to the success or failure of the startup or the company, right? So the business churn that you have inside the company is not going to impact their production environment. So they need technology that can transcend beyond the business of a company or vendor that is selling it. And open source provides a perfect way of doing that. Last but not least, the most important piece of this puzzle has been operations. So once you install, even if you get services or support to install a product, what we have seen is that the challenge really starts after that. When you start operations on day 2, when you want to know what the health of your system is at all points in time, and you need to be alerted if there's something that is degrading before it actually degrades. When you want to do it at a scale that the current clouds, private clouds are going towards. So all of those actually are accelerating a lot of open source adoption. So we're seeing the highest adoption at this time is coming from this operational elements because there are some of the best technologies that I've seen are actually coming out of the security, analytics, monitoring, troubleshooting, and debugging paradigms inside the open source world. So again, going back to more inbound, open source has had a profound impact, whereas for something that a few people sitting in a cube on the side used to do, now it's something that people aspire to do. They join our company because they show a preference to work on open source software. And why is that? So there's certain aspects that are just because developers want to build them, so they want to do a lot of things very quickly, so open source allows them that. So once they get the buy-in from the community, they spend a lot of time buying it, but then they can be very agile in building it. They can quickly roll it out. It will come out in the next release if they can meet the community criteria, and they can be just much faster in their execution. They also have much broader architectural insights, so they basically know what is happening in different communities, how it can impact the product, not only the base technology, but the roadmap of your product. Should we be doing this, and should we be doing it the way we are thinking of doing it, when some other community is also trying to solve the same problem some other way? So we've seen that they have much broader architectural and technology outlooks. They are much more cognizant of the stability blind spots. So they're much better at figuring out what test cases to write, how to test their code, because in the community, if something breaks, they throw your code out. So even if you get in and it has stability issues, they will throw it out in the next release. So just this training, just this constant watch from the community enforces a behavior in them that they just write better tests, they write more stable code, they architect their product better, and they think about the long-term ramification of every design decision that they take. One other very important and interesting aspect is that they actually can open doors that are very difficult to open through other channels. So, for example, we had an issue where we were trying to scale out an OpenStack cloud, and recently we were trying to figure out different options. And there was one partner that we were working with who were key to there was a distribution partner that we were working with whose sort of like insights we had to get on this. So we kept asking different people through product channels, through sales channel, if we can get this information. But eventually the developer, once he got down to the developer who was already engaged in that community from our side, he got those answers in a day. So he went on the community, he posted the questions, got extremely insightful answers. Within 24 hours, we knew what to do next. So these doors are sometimes even impossible to open, and sometimes they take much longer and they're harder to unlock. So that's another important aspect. And if you are into traveling, open source provides amazing opportunities to travel all over to the most exotic locations. These people pick their locations for their conferences in the best places. I know there are people from our company who are in Tahoe right now attending a conference from the Linux Foundation. So yeah, if you're into that, this is a great platform to again join simply for that reason. Now, the last two slides that I have, I'm going to focus on if you are thinking of an open source strategy for your team. How do you pick a project? Which project should you contribute to? Which project should you integrate with? So first of all, how do you pick a winner project? I mean, that to me, if you don't remember anything from this presentation, this is the key point. How do you pick a winner project if you want to contribute to it or get behind it or accelerate it, or you just want to pick it for integration into your base product? You pick the project that has where the quality of the developers is very high, and they're actively invested into it, which means it has very active community discussion forum. It has a CS system that churns out builds very, very frequently. So the releases are coming out, the fixes are coming out very, very quickly. So you need to pick the quality of the developers on that community and the activeness and investment that they're making into building that community. That is the key point. If you pick the community, even if they're lagging behind, I assure you they will catch up, and this has happened to us in 10 different projects that we have picked. Initially, we were also going with, what is the coolest one, who has the best architecture, wiki, but those things eventually fizzle out. What is most important is people will get it right if the right people are working on it and they're spending the right amount of time working on it. So this is the key point when you're picking a community project to either integrate into your project or to contribute back into. Which products should you contribute to? You should contribute to products that you have the core competence in. So they are things that you really know. You're the world-leading experts, and those are the ones where people will value your insight, and they will actually, there will be generally gaping holes. I mean, I've seen in these projects, there are gaping holes that you can actually fill. PLUMgrid is an SDN layer, and there are many other SDN layers for OpenStack. Why? Because OpenStack started as a cloud management system. Networking came much later when they introduced Quantum earlier and then later on Neutron. But networking was an afterthought, so this was not the core of their competence. And that's where, you can make a lot of contribution very quickly and accelerate the community and accelerate your business with it. Which project should you integrate with? Anything that is not the core of your product, do not try to build it yourself. I'll say it again. Since you can, does not mean you should. So do not invest time in building and maintaining things in-house if you don't have to. Integrate with other projects and accelerate their development. So find out projects where they have almost everything that you need, but maybe a few components are missing here and there, and just go and enable them, accelerate their development roadmap rather than trying to build it in-house. Common myths. So I'm going to talk about some of the common myths, and these are the kind of arguments I would hear over the years from PLUMgrid engineering teams as well. And I think they're all incorrect. So let's just go through them. One of them is we can build it better. Even if this argument is correct, first of all, it's not correct for most of the cases that I've seen. But even if this was correct, like I said, just because you can does not mean you should. You have to think about the maintenance overhead of this, and who's going to maintain it, and what is the cost to your engineering organization to maintain it. And the other thing that I hear is, this is a very blanket statement. People say, oh, these guys have great numbers on their community page, and they're talking about a lot of these things, which just sounds too good to be true. And seriously, people don't even try these things out. If you really want to make a meaningful investment, build benchmarking software. If you think really that a particular community project is good or bad or whatever, you want to benchmark it, a good investment that you can do in-house and later on upstream is to build benchmarking tools so that you can keep benchmarking them and seeing whether their claims for performance or scalability are true. And as they improve, you can see the improvement trend as well. The same benchmarking can be used across different projects. We are right now doing it for a database project, for an in-memory database project. So the same benchmarking tools can be used across the different organizations or different community projects as well. So that's a good investment to make if you really want to make that investment. But somebody comes and says, this sounds too good to be true, you say you try it first. So don't accept that, because these community projects very quickly, so sometimes people try them and they're not that good, and then they just ditch them. But they actually have because there's so many developers working on it from across the world, they have a way of becoming mature very, very quickly. So just do not write some project off because it did not work 2 years back. It might have matured significantly since then. One other mistake that people make is that why don't we just fork this software in-house and just maintain it in-house? That's just a bad idea. Unless it's like something core and some secret sauce that you cannot open source. Even if you have a secret sauce, try a way that you actually can stay in sync with the community code base and keep the secret sauce in-house, because forking it will lead to all sorts of maintenance overheads that you just do not want. And the last thing that I heard was, oh, nobody else does it, none of our competitors are doing it, we should just build it ourselves. And this is also a bad excuse, because, I figured out over the years that most of our competitors were doing it, and it's just that you don't know about it. Maybe they're making the same mistakes as you are, but most of them are trying it out in some shape or form. So that's the end of my presentation. I will, at this point, since I don't see any questions, so if there are no questions, I'll hand it over to Sean.
Yeah, let's go ahead and pass it on. Please remember, if you have questions, use the Q&A window, and we will address those at the end of the session. I'm going to hand this over to Sean, and he can kick off his portion.
Okay, so first of all, I want to say thanks to Ali and PLUMgrid for asking F5 to join their webinar today. Looking at open source for F5 is a little bit different than the way that PLUMgrid approached it. And, coming from a traditional large enterprise company who is traditionally a proprietary software shop, making the move to open source was a challenge for F5. And my group, the OpenStack group, was actually one of the first groups within F5 to be able to open source a major project. And so what I want to talk to you today about is kind of how that transition happened, some of the things that drove that transition inside of the company, as well as how we look at open source within F5 from a company point of view, and then some of the challenges that we faced both early on and even currently as we continue to learn more and more about how to use and contribute to open source projects within F5. So if we look at F5 as a company, we've always been a traditional enterprise software and hardware provider. We've built hardware, we've been building hardware for years, we've wrote the software that runs on top of it, and we've traditionally been very protective of our intellectual property. Very reluctant to do any type of open source contributions, Although we've used open source, from different projects, I think that, as Ollie discussed in some of his last slides, there was a lot of forking the code and maintaining it and trying to stay in sync, for the different projects and open source products that we used inside of the product. So we've also, one of the interesting things too about F5 is that we've always had a very traditional software delivery model. So F5's wanted to control that software delivery from start to finish, right? So all the way from building the code to putting it on our website, making you log into our website and having an account and, accepting EULAs and all of the things that, traditional software companies have done. Even shifting away from that has been a challenge to get our heads around here at F5 into a more open source delivery model, whether it be through, a very public website or different package managers and things like that. So, even just the actual delivery of the code has been a challenge for us as we've moved into this model. We've always used open source within the company itself, and not just in the product, right? We've always used open source projects for, build and CI and test and even, within IT and all of those kinds of things. But actually, contributing things back to those projects has been frowned upon, and I think that it ended up, with employees going around the process and actually being able to contribute back in. So, when we look at a fully open or more open company like PLUMgrid, and we look at a traditionally closed company like F5, what we're seeing now is with the explosion of open source, F5 is trying to catch up and understand where their role is in open source code itself. And truthfully, it's somewhere in the middle. As a traditional product company, we're probably, and I don't like to say never, because as soon as I say never, it'll happen, but we're probably never going to open source the core of our big IP software and product, right? But as customers move to these more open frameworks, deploying our product and our software into more open environments using OpenStack or Mesos or Docker and things like that, and as well as orchestrating those things with tools like Puppet and Chef and Ansible, we're forced to move into this open source world and provide the software and tools to help our customers deploy our products in those environments. So, I think that's where F5 for now is going to live in the open source world, is contributing to the projects that help our customers deploy our products, which in turn makes F5 more successful as a company. So how we got there. These are a few of the things that drove open source early on within F5. So first was employee interest, especially around OpenStack. The OpenStack project was born out of two people's vision that open source would be pretty much what it is today, about 3 or 4 years ago. They decided to work with a few customers who were early adopters to OpenStack and figure out how to deploy F5 in an OpenStack environment. And these two guys put in hours and hours of weekends and nights and all that stuff to make this product happen. And eventually it got customer traction. But then the problem came, how do we get a hold of this software? So, they went through the traditional F5 delivery mechanism and all of those types of things. But customers were asking for more, right? So it's always customer demand that ends up driving these things, especially in a large enterprise like F5. The second was education, right? So it was about educating people within F5 that open source doesn't mean we're giving away things for free. We're actually enabling our customers to use our products in a more efficient way, which will in turn allow them to buy more F5 product as opposed to going to something that's easier to deploy and is also open source. That took a lot of education. It took a lot of education with executives, took a lot of education with our legal team, took a lot of education with our support and services teams. In these large companies like this with thousands of people, getting all of the people bought into an open source vision is a big challenge. But over about 6 to 9 months of heavy campaigning and education, we started to move the ball forward. The other was talent acquisition. So we started to hear more and more people as we interviewed them for roles within F5 ask us about what our open source policy was, right? They were very concerned about coming to a company like F5 because they contributed to open source projects and were worried that F5 would keep them from contributing to them, even if they were unrelated to F5. We also saw it as a way to say, you know what, we are starting to contribute to open source. We understand the importance, and it's okay that you want to contribute out. So that really started to help us, both attract and retain our talent. We started to hear more and more of our internal employees saying, I want to contribute to this open source thing. It would be, I have this work that I'm proud of that I've built inside the company and I want to share it with other people because I think it's useful. And, honestly, telling our employees that they can't do that really isn't an option. They're going to go somewhere else where they can, and they're probably going to take the code with them and do it somewhere else. Or they're going to subvert the process and do it on their own in their own private GitHub accounts. But the real driver, I think, was the last three: OpenStack, integrations, and collaborations, right? So just like we're working with PLUMgrid, these integrations that we're doing with PLUMgrid and some of our other vendors wouldn't be possible without us open sourcing the code. So the real pressure came from customers starting to deploy product in OpenStack, using distributions from other companies, using upstream distributions, and starting to ask us, where's F5's code? I don't see F5 in upstream code. We started to hear that more and more and more. Partners were saying, I really want to integrate your code, but there's no way I can give this to the customer if it's not open sourced. So we started to listen. Again, customer demand drove all of this. Without our customers, I don't think F5 would have ever even considered making the shift. But when people are telling you they're not going to buy the product unless you open source your code, companies have a way of listening. So once we started to make the shift to open source, we started to think about, well, how do we view open source within the company? And we split it into two buckets. We split it into the bucket of creation and distribution of open source, as well as the use of open source. And the use of open source was pretty straightforward, whether that be in the product or within the company. The first thing that they did was they made this small team of people who we call our license review board. So anything that a engineer wants to use within the product during the review time and design time of that feature, they list the open source packages that they would like to use. That is submitted to this license review board, and they review those packages and decide, is the license impactful for the product? What are the risks around using it, and things like that. They also track all of these packages then, so that when someone else comes along and says, I want to use the same package again, we don't have to go through this cycle all over again. And again, we do all this at kind of feature design time, so that if someone selects something that doesn't have a favorable license, they can make the adjustment early on in their design process. For company use and personal use, it follows the same thing. We are, I would say, less stringent about that, obviously, because we're not shipping that product out and selling it to make money off of it. So the license matters less than to our legal team. But for creation of open source, we had to go through and develop a whole new process. I don't like to make process for process sake, but there's a lot of moving parts within a big company that we have to think about. And part of that is getting the right sign-off from the right people in the different organizations within the company. So we make sure that we have executive sign-off. And at F5, that's our CTO, Carl Trebes, signs off on any new major open source projects. So a project like OpenStack, our CTO was aware of it. We presented to him what the code did and why we should want to open source it, to reassure him that there's no real intellectual property for F5 in there. There's no value in us keeping it closed source. The next thing that we want to make sure that we do is we talk to our product management team. And this is pretty important because what we don't want to have happen is have someone inside the company open source a project that the product management team is planning on releasing as a product in the next 6 to 12 months, for example. So by getting product management buy-in across the company at the executive level, we avoid those types of pitfalls. Second is the legal review. They consult with us and help us choose the license that we'd like to release our code with. And they work with some outside counsel as well to do that because, again, like I said, as a company, we're still kind of learning what the right things are to do. So they consult with outside counsel, and those 3 sign-offs take quite a while to get done. The OpenStack project itself was about 4 months to go through all of that and convince all of the right people. I'm hopeful that the next major project is less involved because a lot of this was again, that education and campaigning to make this happen, and they're seeing the benefits of it now. So we also do a project commit just like we do with any of the rest of our projects within the company. And this kicks off a lot of the internal processes around support and marketing and all of those things that it takes to build a product. And this is important because the support team needs to understand what level of support they need to provide, right? So we have 3 levels of support that we identify for open source software. It's community supported and community contributed, which means that the support team never actually touches it, and it's just kind of out there for the project community to support and code. We have F5 contributed, which means that a team of F5 engineers are responsible for that project overall. And then we have F5 supported, which means that for customers who have a support contract with F5, they can call into support and get support on that open source code itself. We also talk about, what the development process and quality is, what the strategy is for maintaining high quality. And just like Ollie said, I think that having the code out in the public view makes this a whole lot easier to convince the dev team that they should be doing a better job maybe than they do internally, because other people can see it and they can readily use it. The other thing that I think has made it easier for us for open source code as opposed to internal code is that we get to leverage a lot of the tools that are already out there for CI and test and code coverage and all those kinds of things that we don't have to build. We used to have to build all of those things in-house or replicate them. But now, with GitHub having so many integrations with Travis CI and various tools like that, it made our job a whole lot easier, and we could focus on writing the tests and writing better code as opposed to maintaining and managing the systems to do that. We also have a doc writer on my team that's dedicated to writing the documentation for this, and we do require that individual contributors have to sign a CLA with F5, similar to what they have to sign with OpenStack when they contribute to that project. But again, at the end of the day, all of our open source software does have F5's name on it, and we want to make sure that it's something that we can be proud of. So, the challenges. Once we created this open source project for OpenStack, the demand to open source other things internally inside the company became much greater. We get 1 to 2 new queries a week about, oh, I have this code that I want to share and I want to distribute and I want to open source it. And so, managing those calls and kind of herding the cats around, there's a process that you have to follow, like it or not. You work for a company who has this process and you have to follow it. The other one is, who actually owns and maintains this code between support and PD? Like Ollie said, there's a lot more access to the actual developers that are writing this code through these open tools, and it's taxing on the development team to get that done. And with that easy access, our customers are less likely to go through their traditional support means to get this done. It's both good and bad. I feel like we do a good job of supporting it, but at the end of the day, it is a little bit taxing on the dev team if you're not ready for it. We still do have to manage our GitHub account and some of the other tools and accounts, and that's a challenge in a large organization as well. Who sets up the account, who manages it, who's allowed to add new accounts to GitHub and things like that. is always a question that we struggle with, and we're working through a lot of those issues. And then one of the biggest challenges for us is just integrating some of these things with our internal tooling, especially around support, because they have a case management system that they use. They don't use GitHub. We use GitHub for our issue tracking and our wiki and all that kind of thing. So tying those systems together and training the support engineers on how to take cases and file bugs and things like that are a little bit of an overhead, as well as our release cycles. Our release cycles are much more rapid for our open source projects than they are for our internal traditional product line. And then finally, again, just continuing the constant communication and education about what these projects are and who maintains them and who owns them, is a bit of an overhead, mostly on the management staff, but the engineers do have to deal with it once in a while as well. So that's really all I have. I wanted to make sure, I rushed through a little bit at the end. I wanted to make sure we did have time for any questions that were out there as well.
Yeah, great. So we're going to go ahead and move into our Q&A session. Thank you, Ali and Sean. So we do have some questions that have popped up, so I'll just take them as they come. If you guys are on the line and have questions, please use the Q&A panel, and we'll do our best to address them either live or after the event. So first up, let's see what we have here is how do you manage open source obligations of publication of any changes or enhancements to open source while you make use of open source and your products in the IP protection? So Sean, this came through during your session, so.
Sure. Yeah, so like Ali said, I think we, for better or worse, fall into the we fork the code and maintain it ourselves. The license, for example, I was part of the line rate systems acquisition, and we were based on FreeBSD. And we put a few things back into the OS itself as far as bug fixes and things like that. We did not put our IP back, but the license allowed us to do that. So a lot of it is careful examination of the license and understanding really what your obligations are prior to choosing that package to be included into your product. That's why we have the license review board internally for use, so they help us understand what those obligations are, and then the product team gets on board with whether or not they should be using that inside and whether they would ever have to contribute their IP back.
Okay, thank you. Let's see. Which elements, so this looks like it's for Ali, which elements and stages of the product lifecycle are seeing the most accelerated adoption of open source components?
So the one that, like I said earlier, the one that I'm seeing the most accelerated growth in is operational tools. So the tooling around operations, security, monitoring, troubleshooting, debugging is the one where the tools have really, evolved significantly in the past year and a half or 2 years. The other big aspect that I see, and which has been used pervasively by almost everybody, like Sean mentioned as well, is the CI/CD adoption. So those are also tools that are very heavily used in all organizations.
Okay, let's see. So there's a question for F5. How do you decide what code to open source?
That's a really good question. Mostly right now it's based on customer demand and how they intend to use it. We've been struggling a little bit internally to figure out that question. Right now, I think the easy answer is if someone asks us to open source our core product code, we say absolutely not going to happen. But if they're saying, we would really like to be able to manage your devices using Chef and we need a Ruby API, we would absolutely write that Ruby API and open source it if we had the right resources available. So for most of ours is looking at what it's integrating to, how the customers are going to use it, and what IP, if any, is inside of there. And we wouldn't consider an SDK, for Ruby that talks to our REST API any kind of intellectual property. It's no different than logging into the box through SSH and entering the command. So that's something we wouldn't hesitate at. It gets a little bit more tricky for us if we look at doing, plugins that enable some of our competitive projects to, for example, log and do visibility into one of our visibility systems. That gets a little bit more tricky. Like, do we want to actually contribute back to a competitive project? Sometimes the answer is yes, and sometimes it's no. It's all business case for us at F5.
Great. Okay, let's see. Next we have what licenses, so this looks like it's for PLUMgrid, what licensing model is being followed by the open source technology created and consumed by PLUMgrid?
So that's a very good question. So the technologies that we have been adopting are generally fall into two licenses. So one of them is the GNU license. Everything that goes into the Linux kernel is basically GNU. But by and large, the software that we were using so far is Apache licensed. So most of it is Apache, and the one that we are releasing is also under an Apache license. Having said that, this is becoming increasingly confusing, the licensing. So the next step for PLUMgrid is to kind of have what Sean mentioned. F5 has like a license review board, so that's the next step that we are currently working on, because it's becoming very confusing.
Okay, let's see. So we have.
I have one more question over here from Rod.
Okay.
What additional impacts and challenges do you see happening with PLUMgrid and open source?
Go ahead.
Okay, so I see the question from Rod. What additional impacts and challenges do you see happening with PLUMgrid and open source in the upcoming years? So the two main challenges that I do see is the first one I just mentioned, that this licensing thing is becoming very, very tricky, because now there are all sorts of different licenses, and it's becoming difficult, more and more difficult to decipher. And we are working on building a process for license approvals and license reviews before we integrate anything into our product. So that is one big technical challenge. The second big challenge is actually many of the communities have very stringent rules as to what they allow to be upstream and what they don't allow to be upstream. So if there's any component of your backend product that is closed source, for example, any component, then OpenStack does not let you upstream all of it. They will only allow you to upstream things that are directly tied to, in our case, for example, the Neutron plugin, which is fully open source. So in that case, you actually have to have a three-stage model where, because that code still keeping it in-house does not make sense, because sometimes your customers even your partners want to make changes to that code base. So it introduces this new level of maintenance where you have your internal code base, which is closed source. Then you have a GitHub account where all the things that you consider are non-proprietary and should be out in the open source, but the community is not willing to accept. They sit on the intermediate GitHub layer for the company, and the third one is the upstream repository. That's becoming, from a management perspective, a code management perspective, it's challenging and tricky, but it is still better than bringing all of that code in-house, because we have active developers from our customers' DevOps teams as well as our partners who actually contribute into those code bases. So bringing their code into our internal code bases is going to be a nightmare, so it's still better than that. So those are the two big technical challenges I would say in the upcoming years.
Okay, and I think we have time for one more question. Let's see. They're asking, are you on Slack, and how do we join?
So our team does use Slack here at F5, and for our OpenStack code, and we actually, we obviously participate in the IRC for OpenStack as well, but we found that Slack works better for our team members, and it's a little more friendly for our customers and our users. They can join that by going to our OpenStack webpage, F5network/OpenStack, and there's a link on there to get invited into that channel.
Okay, great. So there's just a couple of minutes left, so let's go ahead and just quickly wrap this up. I want to thank Ali and Sean for joining us today and providing us with some different perspectives on the open source community and what they've seen and what their companies are doing. So thank you for joining us. As always, please follow us on Twitter. You can follow PLUMgrid at PLUMgrid and S5 at S5 Networks, as well as Sean. Sean's on Twitter and active. So please stay connected. If you have any questions after the event, please feel free to email events@PLUMgrid or reply to one of the emails about this event, and we'll help answer your questions and get you connected however you need to. So thanks for your time. Thanks for joining us, and have a great day.